The last signal humanity ever sent into deep space left Earth at the speed of light, 300,000 kilometers every second. The fastest thing the universe allows, and in cosmic terms, it is embarrassingly slow. That signal is out there right now, still traveling, already billions of kilometers from where you're sitting. And yet, in a galaxy 100,000 light years wide, that signal hasn't even crossed the street, hasn't even reached the nearest neighborhood, has barely moved in any meaningful sense at all. This is not a conversation about whether intelligent life exists out there. It almost certainly does. The math demands it. The numbers are too staggering, the universe too vast, for Earth to be the single exception in a sea of empty worlds. No, the question isn't whether they exist. The question is far more unsettling than that. The question is why, if there are civilizations out there, perhaps millions of them, the universe has made it structurally, physically, fundamentally impossible for any of them to ever stand on this planet. Not improbable, not unlikely, impossible. And the answer isn't a lack of intelligence. It isn't a failure of technology. It is something far more ruthless. It is the universe itself, its geometry, its laws, its sheer scale, acting as a permanent, inescapable wall between every civilization that has ever lived and every civilization it will never meet. Stay with this, because by the time this is over, the night sky is going to feel very different to you. You need to feel the distance before you can understand the barrier. Not understand it intellectually, feel it. The closest star to our sun is Proxima Centauri. It sits 4.24 light years away. That means light itself, traveling at the universal speed limit. The fastest physically permitted to exist takes 4 years and 3 months to cover the gap between our sun and our nearest neighbor. Now translate that into something familiar. The fastest spacecraft ever launched by human civilization was NASA's Parker Solar Probe. At peak velocity, it travels at approximately 692,000 kilometers per hour. That is genuinely staggering by human standards. Rockets, fuel, engineering genius. And we managed to push metal through space at nearly 200 kilometers per second. At that speed, to reach Proxima Centauri, the journey would take approximately 6,300 years. Not centuries, not a human lifetime, not even a civilization's lifetime as we currently understand one. 6,300 years. More than double the span from the construction of the pyramids to this exact moment, and Proxima Centauri is our closest neighbor. The Milky Way galaxy, the spiral structure we call home, is 100,000 light years wide. If a civilization existed at the far edge of this galaxy and pointed their most powerful telescope toward Earth, the light they'd be seeing right now left our planet before Homo sapiens existed as a species. They wouldn't be watching human civilization. They'd be watching our evolutionary ancestors navigate a world we would barely recognize. And within just our galaxy, the distance between star systems averages several light years. Multiply that across 100 billion stars, and you begin to approach the actual scale of the obstacle. Not the river to cross, not the ocean. A geometry so vast that distance itself becomes a kind of sentence. But distance alone isn't what makes this impossible. It's what the laws of physics do to anything trying to cross it. Here is a fact so stark that most people, upon hearing it clearly for the first time, simply don't believe it. To accelerate a spacecraft carrying a single human being, say a vessel with a mass of roughly 100 metric tons, including fuel and life support, to just 1% of the speed of light, you would need energy roughly equivalent to the total annual energy output of every power plant on Earth combined. Every coal plant, nuclear reactor, dam, solar array, and wind turbine, all of them running for an entire year to push one small ship to 1% of light speed. 1%. At 1% of light speed, reaching Proxima Centauri would take 420 years. Still impossible for any crew that intends to survive the journey. To reach even 10% of light speed, still a journey of 42 years to our nearest neighbor, The energy requirements climb into territory so extreme they effectively don't exist in any practical engineering reality. The fuel mass alone becomes greater than the mass of the ship, then many times greater than the mass of mountains. The math spirals into absurdity very quickly. This is not a problem that engineering will one day solve. It is not an obstacle waiting for the right invention. It is a hard constraint embedded in the relationship between mass acceleration and energy, a relationship described by physics that has been tested and confirmed across every experiment ever conducted. Now consider this is just for a nearby star, a single step in a galaxy containing over 100 billion of them. For any civilization attempting interstellar travel to Earth from another star system, not 4 light years away, but perhaps hundreds, perhaps thousands, the energy barrier scales accordingly, exponentially, past the point of any coherent technological solution, past the point where more advanced civilization solves the problem, into the territory where the problem is simply the structure of physical reality itself. Even if a civilization somehow overcame the energy problem, assume they did, accept it as given, they face an obstacle that technology cannot resolve at all. Time, a journey of hundreds of light years at even a significant fraction of light speed takes hundreds of years. Any crew that departed would die long before arrival. This is solvable, in theory, through generation ships, vessels so large and self-contained that multiple generations of travelers would be born, live, and die aboard them before the destination was reached. A civilization that chose to do this would be sending their descendants, not themselves. But consider what that means for a civilization attempting to reach Earth specifically. They would need to know Earth is worth reaching before they left. They would need to detect it, analyze its atmosphere for biosignatures, determine it harbors intelligent life, decide to make contact, and then begin a journey that would take longer than the entire recorded history of human civilization, all before a single ship left the ground. And here's what makes that nearly impossible. When they detected Earth, they were seeing Earth as it was in the past. If they are 1,000 light years away and observed our planet today, they are observing light that left Earth in the year 1024. They are watching the early medieval period. No radio signals, no cities visible from space, no detectable technology, nothing that would signal intelligent life at all. The faster they can travel, even at extremely optimistic fractions of light speed, the more they are racing against a timeline that doesn't favor them. The universe's speed limit means observation and arrival are always separated by an enormous, often civilization-ending span of time. They depart toward a world they can never fully know. They arrive, if they arrive at a destination that may be unrecognizable compared to what they left toward. But let's go further. Assume they've solved the energy problem. Assume they've solved the generation problem with some form of suspended biology or extended lifespan. Assume they're traveling at a significant fraction of light speed, say 70 or 80%. Now physics introduces its most philosophically devastating barrier. At relativistic velocities, time itself behaves differently for the traveler than it does for the rest of the universe. This isn't metaphor. It isn't approximation. It is a measured, observed, experimentally verified property of space-time. A crew traveling at 80% of the speed of light experiences time passing roughly 40% more slowly than an observer at rest. For the travelers, a journey of 1,000 light years takes perhaps 600 years of their experienced time. Still enormous, still several generations, but manageable perhaps. For the civilization that sent them, for the world they left behind, the journey takes over 1,200 years, over a millennium. The world they launched from has had 12 centuries to change. Their institutions, their language, their civilization itself, none of it is guaranteed to survive that long. History tells us very clearly how rare that kind of continuity actually is. They leave from one civilization and arrive, if they arrive, as orphans from a world that may no longer exist, as visitors from a dead culture. seeking contact with a civilization that has no reason to trust them and every reason to be afraid. And yet, even this isn't the final wall. Imagine a civilization that somehow overcame every barrier described so far: the energy, the time, the relativistic complications, the generational gap. They exist, they're real, and they're pointed toward Earth. The observable universe contains somewhere between 200 billion and a trillion galaxies, each galaxy containing hundreds of billions of stars. The distances between galaxies make the distances between stars look like stepping stones. The nearest large galaxy to our own, Andromeda, is 2.537 million light-years away. At the speed of light, that is a journey of 2.5 million years. For any civilization not in our immediate galactic neighborhood, the idea of reaching Earth isn't just difficult, it isn't just energy-intensive or time-consuming. It is physically outside the structure of what is achievable before the civilization itself collapses under the weight of entropy, stellar death, and the slow heat death of local stellar resources. And even for civilizations within our galaxy, a volume of space in which every obstacle already described applies in full force, there is one final crushing reality. For them to reach us, they must have survived. Civilizations are fragile. Intelligence doesn't guarantee permanence. Every species capable of building spacecraft first had to survive its own technological adolescence, its own aero weapons capable of self-destruction, of climate pressures, of the thousand ways a civilization can collapse before it ever looks outward. The universe is not filled with stable ancient interstellar travelers waiting to cross the void. It is filled with windows, civilizations that exist for a few thousand years, or a few 100,000 at most, and then are gone. The universe is 13.8 billion years old. Most of the stars that ever existed are already dead. Most of the civilizations that ever arose, if they arose, have already passed. The timing problem alone, independent of all physics, makes the probability of aligned, mutually aware, simultaneously spacefaring civilizations vanishingly small. The universe is not silent because it is empty. It may be profoundly, extravagantly full of life, but it has built its prison walls from the most fundamental materials available, from the geometry of space itself, from the relationship between mass and energy, from the flow of time and the way that flow bends at velocity, from the gap between the moment the civilization rises and the moment it falls. There are likely minds out there, perhaps billions of them across billions of years, that looked up at the same darkness you look up at tonight, that felt the same wonder, that built their telescopes and pointed them outward and found only the same silence, not because the universe is lonely, but because the universe is unimaginably large, and it has made the price of crossing it higher than any civilization can realistically pay. That is the answer. Not a conspiracy of silence, not a filter we haven't passed, not a lack of intelligent life. The answer is physics. The answer is scale. The answer is time and energy, and the cold geometry of a universe that does not bend its rules for anyone, not for us, not for them, not for intelligence itself. We are not alone. We have almost certainly never been alone, but we are and will very likely remain forever separated from everything else that has ever existed by barriers not of our making and not within our power to remove. The stars are full. The distance between them is simply too great to cross. And that, in the end, is the most profound thing the universe has ever told us about itself.